Welcome to The Explainer. Today, we're breaking down the fundamental states of matter that make up, well, everything around us. From the chair you're sitting on to the air you're breathing, it all comes down to three basic forms.
So check this out. It's just a glass of fizzy water with some ice. You've seen this a million times, right? But stop and think about it for a second. You've got solid, liquid, and gas all just hanging out together. But what's the deal? Why do these three forms of the exact same stuff, in this case water, act so completely different from each other?
To really get it, we've got to look a little deeper, past what we can just see. It really all boils down to a few key characteristics that define how each state of matter behaves. So let's break it down. Okay, first things first. Let's talk about the properties we can actually see and measure. This is kind of like the what's happening part before we get to the why it's happening part. Okay, so solids. Super simple, right? Just think of an ice cube. It's got its own shape, it takes up a certain amount of space, and that's that. You can pop it out of the glass and into a bowl, and guess what? It's still an ice cube. Its shape and volume are fixed. But then, what happens when that ice cube melts? You get water, right? And that's our liquid. Now, it still has a definite volume. You've got the same amount of water you started with, but it doesn't have its own shape anymore. Nope, it just molds itself to whatever container you pour it into. A tall glass, a wide bowl, it doesn't care. And that brings us to gas. Think about those little bubbles in the drink. Gas is, well, it's a total free spirit. It has no set shape and no set volume. It'll just expand and expand and expand to fill every single nook and cranny of whatever space it's in. So, let's just put that all side by side. A solid holds its own shape and volume. A liquid keeps its volume but takes the shape of its container. And a gas, it just takes over the whole container, shape and volume. It's a really clear way to see the differences, but it still doesn't tell us why. Why do they act this way on a deeper level? And to get to that why, we need to go small, like really, really small. We've got to zoom all the way down to the microscopic level and look at the tiny little particles that make up everything. This is where we get to something called the particle model of matter. And here's the big secret. Whether something is a solid, a liquid, or a gas, it's all made of the exact same kinds of tiny particles. The only difference, the only thing that changes, is how those particles are arranged and how much they're wiggling around. And this is a perfect picture of what's going on. Look over on the left at the solid. See how the particles are packed together in this really neat, orderly grid? Now look at the liquid in the middle. The particles are still pretty close, but they're not locked down. They can kind of slide past one another. And then you've got the gas on the right, where the particles have just gone totally wild. They've broken free and are just zipping all over the place. Really, it all boils down to two things: how much energy the particles have and how strongly they're attracted to each other. In a solid, those attraction forces are super strong, so the particles are locked in place, just vibrating. In a liquid, they've got a bit more energy, enough to overcome those forces and slide around. And in a gas, they've got so much energy that the forces between them are basically nothing. They're free to just fly off in any direction. All right, so gases are just a bunch of particles flying around, right? That's why they're usually invisible and all seem the same. But what if we could use the fact that their particles are different to actually tell them apart? Let's put that idea to the test. So, picture this. You've got three jars in front of you. They look empty, but they're not. Each one is filled with a different, totally invisible gas: oxygen, hydrogen, and carbon dioxide. How in the world could you tell which is which? Well, because their particles are different, they're going to react differently. And we can see that with a really simple experiment called the splint test.
The whole process is actually pretty easy. You just take a small wooden stick, that's the splint, and you can either have it burning with a flame, or you can light it and then blow it out so it's just a glowing ember. Then you stick it into each jar of gas and just watch what happens. And what you see is basically a unique fingerprint for each gas. If you put that glowing splint into the jar and it bursts back into flame, boom, you've got oxygen, because oxygen loves fire. Now, if you take a burning splint and stick it in, and you hear this little squeaky pop sound, that is the classic sign for hydrogen. And finally, if you stick the burning splint in and the flame just goes out, poof, that's your carbon dioxide. See? Three totally different gases, three totally different results. Pretty cool, huh?
All right, so let's bring it all home. After everything we've talked about, what are the big takeaways here? So you've got the three main states: solid, liquid, and gas.
And all their different properties, everything that makes them what they are, can be explained by how their tiny particles are arranged and how they're moving. And we can even use those properties to do cool stuff, like using a splint test to figure out what gas we're looking at. The main thing, really, is that the big visible world that we see and touch is all run by this invisible microscopic world of tiny dancing particles. And when you get that, you're starting to understand what matter itself is all about.
So we've covered the big three, right? Solid, liquid, and gas. They're the ones we see every day. But are there more? What about something crazy like lightning or the stuff inside the sun? Could there be other states of matter out there? Ones that are way more extreme? Something to think about. Thanks for joining me on this one.